We have a great team working on this new product, and we are really excited to reach this important milestone and show you what we have built. Let's start with the Verrazzano.io website, where you can find information about Verrazzano and how to connect with us on Slack or Twitter. You can access our documentation right here. It includes a wealth of information about how to get started, about all of the options to configure Verrazzano, and about our sample applications. From here, you can access our GitHub repository where you can see our source code. We do all of our development in open source. You can access and download releases, and you can open issues right here in GitHub. Customers can also open service requests with Oracle support. Let's take a look at a running environment. Here I have two Kubernetes clusters. I'm using OCI's Managed Kubernetes Service, commonly called OKE. My first cluster is in the Phoenix region. It's a 3-node cluster, one node in each of the 3 availability domains, giving me excellent availability characteristics for my applications. This is my Verrazzano admin cluster. My second cluster is in the Ashburn region. It's a similar size, and this is a managed cluster where you would run your application workloads. I'm also using the OCI DNS service to manage my DNS zone. Most of these records that you see here are automatically created by Verrazzano for various system and application endpoints. Now let's take a look at the Verrazzano console. It's protected by Keycloak single sign-on, like all of our system interfaces. On the main page here, we can see information about the environment itself and the applications that are running. We include Rancher Server to manage all of your Kubernetes infrastructure across multiple clouds and also on-prem. You can use Rancher to see details of your clusters and to provision new clusters. You can drill down to manage all of the Kubernetes resources in your cluster. Here's an example of the namespaces in my admin cluster. And here we can see the pods. You can also see ingresses and all kinds of other resources. You can easily access logs or even open a shell inside a container to do some debugging. Here, for example, you can see the logs for this WebLogic admin server. These logs are also sent to Elasticsearch or OCI logging for consolidated log management and search. We use the OAM Open Application Model to describe the components of the applications in Verrazzano and how we compose those components to build our applications. You can describe the components and provide traits to provide specific behaviors like scaling or ingress. We've been participating in the OAM standards meetings for about a year, and we've implemented some OAM controllers in the Verrazzano product. So let's take a moment to look at a sample application. This one is called Bob's Books. This sample contains traditional Java EE applications running on WebLogic, along with coherence data grids and a series of microservices built with Helidon, our Java microservices toolkit. Here you see a coherence component described using the OAM standard. Here's a Helidon microservice and another. And here's a WebLogic domain. So this file is defining all of the components that we can use to build our application. This file is the OAM application configuration. So this is taking those components and applying some specific behaviors. You see there a scalar trait and also some ingress traits that tell Verrazzano which endpoints should be exposed outside of the cluster. Verrazzano uses this information to work out how to configure the network and security for the applications. Here in the back in the Verrazzano console, you can also see details of the OAM components, as well as the clusters, and also Verrazzano projects, which are used to provide application isolation and security. You can also drill down to see more detail about any of these things. From the console, we also have easy access to the observability tools that are included with Verrazzano. We automatically configure these and wire up your applications to collect logs and metrics for you. Here's one of the sample applications, the to-do list application. It's really a basic application, but you can see here that I can access it using the automatically created DNS name that Verrazzano created in my zone for me. Also, notice that Verrazzano obtained a production X509 certificate for me and set up the ingress to use HTTPS transport. We do also support Magic DNS and self-signed certificates for development and test use cases. So if you don't have a real DNS zone and certification provider, that's okay. Let's look at some of the security work that Verrazzano does for us. First, let's look at the Istio authorization policy. This is configured to allow our monitoring and management tools and the Istio ingress gateway to have access to send traffic to this application. We also have destination rules that control the traffic. And we configure Istio in mutual TLS mode so that all of the traffic is encrypted, and we use service principals for authentication. Verrazzano also creates network policies like the one we see here so that you can have layer 4 protection in addition to layer 7 if you have a CNI like Calico that supports it. This to-do example application is also the subject of this lift and shift guide in our documentation. This provides detailed step-by-step example that show you how to take a WebLogic application running in an on-premises environment with a database and use our WebLogic Kubernetes toolkit, open source tools to discover the configuration of the domain and collect all of the application binaries and turn that into a Docker image that you can easily run in Kubernetes and Verrazzano. This is a great example of how you can modernize existing applications by moving them into a cloud-native environment. Let's go back and take a look at some of the observability tools now. We provide a set of common open source tools out of the box, and you also have the option to use cloud-native tools like OCI logging and monitoring, as well as or instead of the open source tools. Verrazzano collects all of the logs from containers and applications in Elasticsearch. We provide Kibana, which is what you see here, to access that information. Kibana can be used to drill down, for example, into specific fields. We can filter by hosts. We can search for keywords, limit the time period that we're looking at, and there's a lot more great functionality for mining the wealth of information in our log data. Of course, you also have the option of using OCI logging. Here's an example of some WebLogic logs in the OCI logging interface. If we open one of these log messages, you can see the standard WebLogic log information presented here, and you have the same kinds of capabilities to search and drill down as Kibana. We also include Prometheus and Grafana. We automatically collect infrastructure and application metrics using Prometheus. We have several out-of-the-box dashboards for Grafana that you can use right away. This one is the node dashboard. You can see information about your infrastructure, including details of the kernel, CPU usage, and all kinds of infrastructure level information. We also have a WebLogic server dashboard, which gives us easy access to WebLogic specific metrics like heap usage, performance of web applications, and so on. Let's take a look. Here's that same to-do domain that we were just looking at. You can see CPU and heap information here, some information about HTTP sessions and response time, data sources, and so on. We also have pre-built dashboards for coherence and Helidon workloads. And of course, you can build your own dashboards, customize the ones we provide, and you can use cloud-native tools like OCI monitoring as well. Now let's take a closer look at this to-do list application. Right now, it's running in the admin cluster. It has two pods, one for the database and one for the WebLogic server. Notice that these have extra containers. These are things like Envoy and our logging and metrics collectors. Let's pretend we want to move this application to another cluster and another region. We can open the OAM application configuration file and find the placement section. This controls which cluster this application is deployed in. When we edit this, Verrazzano will see the change and move the application for us. When you use a global DNS service, like the one provided by OCI, you can have a stable host name for applications, regardless of which cluster or cloud region or even cloud vendor they are running in. Let's watch now in the managed cluster to see the new pods starting up. We use the standard open source tools that we've developed for WebLogic, Kubernetes, and Helidon to run these applications. For example, this WebLogic domain is being run by the WebLogic Kubernetes operator. You can see the introspector pod is running, and now it's starting up the admin server, which is running the application in this particular domain. Our Bob's Books sample application has a lot more components, and we use it to demonstrate modernizing traditional applications using microservices and in-memory data caches. Let's take a look at the various components of that sample application in the Rancher interface. The Bob's Book sample is based on a bookstore idea. Here is one of the user interfaces. Let me open it. This one is written in React and running as a Helidon microservice, and it accesses a coherence data grid to get the book data. There's another microservice that accepts orders and sends them to this particularly ugly backend application that we have here. There's a second user interface called Bobby's Books. This one is a JSF Faces application running on a WebLogic server domain. It sends orders to the same backend system. So this has been a quick tour of Verrazzano Enterprise Container Platform, our new product for running traditional applications alongside new modern cloud-native microservices applications with the same kinds of capabilities for security and observability and management across multiple Kubernetes clusters and multiple clouds.